Welcome back, friends. After we conducted our analysis for our model, it's time to express the deflection for our model. So by clicking on deflection here, this is the deflection icon. You can show the deflection by the load cases by clicking on apply. You can see the deflection for your dead load case, and here you can find the deflection for your live load case. When you put your mouse on anywhere on the model and remove it, you can see here on the bottom ribbon, you can see the maximum deflection and the minimum deflection expressed as millimeter units. By clicking on combination, you will express your load combination effect for your model. By clicking on apply, you can see the deflections for your model. And here is the other load combination. Here in this combination, we increased the loads by 20% for the dead load and 60% for the live load. We will dive through all these details in our new and more advanced tutorials. We will had enough for this window for now. We will close it. From show undeformed shape option, when you click on it, you will restore your original model shape. From this option, display frame peer spandrel link forces, you can see your frame forces. Moment 3-3 will express the moment for the axis 3-3. We will dive through all these components philosophy, how they are calculated, how they are referred to, on which axis they esteem their bases. However, you click on moment 2-2 to express moment on the 2-2 axis. We will explain the x, y, z coordinates and the 1, 1, 2, 2, 3, 3 axes, and how ETABS understand the global and local coordinates and how to control them. Here you can express your torsion moment. Here you can see the in-plane shear, in-plane moment. Well, you can't see them because they are they don't appear for our model because we did not define anything in plane or in-plane shear or in-plane moment, and there is no load causes them on the model. Here you can find the axial forces. We will express many models. We can see in-plane moment and in-plane shear in them, and how can we translate them and how can we design for them, what their effects on the model. Here you can express shear 2-2, shear 3-3. An important option here, display options, show values at controlling stations on diagrams. You can see the values of the shear on your diagram or any forces or stresses or moments acting on your model. We will have enough by expressing those frame moments and forces. Slabs are not analyzed in our model because we did not define strips for the slabs. In the next new advanced courses, we will dive through all these details. My goal in this tutorial is to how model in ETABS and the basic steps for modeling a model. So the last thing we have to see is adjust our view to our base view. Then you click on display support or spring reactions, and now you can see your reactions. Click on tabulated and you click on apply. Here you can find FZ reactions, the reactions and the Z direction. Here you can see the FY direction also with the FZ. Here you can see the FX direction mx, my, and z. These represents the moments around the nodes of the base, which demonstrates on the reactions generated on the nodes by our model. We will had enough by expressing those reactions. Also an important note, here you can see the combination reactions. As you see, they are increased. We will had enough for this tutorial by those basic steps to model an ETABS. I hope this tutorial was beneficial for you, and please do not hesitate by asking any questions or any inquiries through comments. I wish you the best and keep training on this model or creating similar models. Maybe you can change the units, change the forces, and I will make sure that you will create more complex models in our next tutorials. See you on next tutorials.